Welcome to the next episode of the Microbiology Tube. So today we'll be talking about the glycolysis and how to quickly memorize the glycolysis. So I have divided the strategy of memorizing the glycolysis into the two parts. So one is the Kike and next is the technique. So overall the formula is the Keycard technique. So here I have taken the words from the enzyme's name. For example, the K stands for the kinase enzymes, I stands for the isomerase enzymes, A stands for the aldolase enzyme, D stands for the dehydrogenase enzyme, M stands for the mutase enzymes, and E stands for the enolase enzymes. So actually there are the functions of the enzymes. The K or the kinase enzymes is responsible for additions or the removal of the phosphate. So whenever there is the employment of the kinase enzymes, there is either the utilizations of energy or either the generations of the ATP. So similarly, I denotes the isomerase enzymes, which will change the structure of the compound. Aldolase will cleave as the 6 carbon compound into the 3 carbon compounds. It means from the 6 carbon compound, two different compounds which are 3 carbon compounds will be released. So next is the dehydrogenase enzymes. It is responsible for removing the hydrogen ions, and it is also responsible for the productions or the generations of the energy. Next is the mutase enzymes. This mutase enzymes is responsible for changing the positions of the functional group, and the last one is the enolase enzymes, which is responsible for removing the H2O molecules. So actually if you remember this work of these kinds of the enzymes, then overall the glycolysis is very simple and you can memorize the glycolysis throughout your life with the formula called the Keycard technique. So if you see here, I have divided the Keycard technique formula into the two parts. One is the Kike. So what you have to remember in this step is that this step is the energy utilizing steps. So you can see here the K stands the Kike in the Kike. The K stands for the K stands for what? The K stands for the kinase enzymes. I stands for the isomerase. Again, next enzymes, K stands for the kinase, and next is the aldolase enzymes. So there is the two kinase enzymes in this step. So in this two kinase enzymes, so what happens is that this K represents the consumptions of the 1 ATP. This represents for the consumption of 1 ATP, and this K also represents the consumptions of 1 ATP. So here in this step the 2 ATP will be utilized. So similarly the next features you have to remember about the Kike is that in this steps the 6 carbon compound is converted into the 3 carbon compound. So 6 carbon compound will be converted into the 3 carbon. So there will be the 3 carbon compound will be changed. So these steps will do that one. So if you see here in the glycolysis, this step I have named this step as the Kike steps. So in the first there will be the involvement of the kinase enzymes called as the hexokinase. So you can call it as the hexokinase or you can call it as the kinase, because if you see here, actually the enzymes that act here is the kinase enzymes. Actually the enzymes acted on here is the kinase enzymes, but what is the substrate it has acted? It has acted on the glucose. So what will be the enzymes? The enzymes you can call it as the glucokinase or you can call it as the hexokinase. So if you see here in this first part, there is the K, and there is the I, there is the K, and again there is the A. So if you see the kinase enzymes, this kinase enzymes will convert the glucose into the glucose 6-phosphate. So what actually it will do? It will conserve the ATP. It will consume the ATP, and it will transmit or it will make the ATP into the ADP. So at that time it will give the 1-phosphate to the glucose molecule. So there will be the glucose 6-phosphate will be formed. But one thing you have to remember is that whenever there is the employment of the kinase enzymes, the reaction are irreversible. I repeat, all the reaction in the glycolysis are reversible beside those reaction in which there is the involvement of the kinase enzymes. So here you can see there is the involvement of the kinase enzymes, so this reaction is the irreversible reaction. So similarly, the next enzyme that will act will be the isomerase. So what is the work of the isomerase enzyme? It will just change the structure. So from the glucose it will change into the fructose. So it actually happens here. So what is the enzyme then? It will be the phosphoglucoisomerase, or you can also call it as a phosphohexoisomerase. So then after what is the enzyme that will act in it? Is the kinase enzyme. So it will change the fructose 6-phosphate to the fructose 1,6-phosphate. So what will it do? The ATP will give the 1-phosphate to the fructose 6-phosphate, and it will make the 1,6-phosphate. One phosphate in one carbon end, and next phosphate in the 6 carbon end. So there will be the fructose 1,6-phosphate will be there, and you can see again here the reaction is irreversible because there is the involvement of the kinase enzymes. So next is the fructose 1,6-phosphate is converted into the glyceraldehyde phosphate due to the enzymes called the aldolase. So this aldolase will convert the fructose 1,6-phosphate into the glyceraldehyde and the dihydroxyacetone phosphate. So dihydroxyacetone phosphate is again converted into the glyceraldehyde 3-phosphate by the enzymes called the isomerase. So this is all about the first step, which I have named as the Kike. So K stands for kinase, I stands for isomerase, again next K stands for the kinase, and last A stands for the isomerase. So overall this is the energy consuming steps. So here the energy will be consumed. So next step is called the DECMake step. So D stands for the dehydrogenase, K stands for the kinase, M stands for mutase, E stands for enolase, and K stands for again the kinase. So if you see here, so DECMake is the energy releasing step. So it means energy will release in that step. The first Kike step was energy consuming step, the DECMake is energy releasing step. So energies are released in the form of NADH and ATP. The D is called the dehydrogenase, so it will generate the ATP in the form of NADH, and K, there are 2 K that will generate the energy in form of ATP. So now if you see here, there is written there is 2, it means there are 2 compounds of glyceraldehyde 3-phosphate, because the dihydroxyacetone phosphate is converted into this dihydroxyacetone phosphate is converted into the glyceraldehyde 3-phosphate. So there is the 2 glyceraldehyde 3-phosphate. So all these 2 represents there are 2 compounds. This here is also okay. So now the first is the DECMake step. So if you see, there is the dehydrogenase. So dehydrogenase, what is the work of the dehydrogenase enzymes? The work of the dehydrogenase enzyme is to remove the H. So its work is to remove the H. So it will remove the H here, and what would happen? It will synthesize energy. And if you see here, the reaction is reversible. Only the kinase enzymes is irreversible. NADH has reversible reaction. So dehydrogenase enzymes will it will do? It will remove the 1H, and it will make the energy, So next step is the DK. Next is the K enzymes. So K enzymes, what will it do? It will act in the 1,3-bisphosphoglyceraldehyde. In the 1,3-bisphosphoglycerate, what will it do? It will release the energy. So here ATP is consumed and ATP is released. So this is the form of energy. And if you see here, the energy of the reaction is irreversible reaction. So one thing you have to remember is that in the glyceraldehyde 3-phosphate, what was the enzymes? Dehydrogenase. So overall the substrate is the glyceraldehyde 3-phosphate. So the enzymes will be the glyceraldehyde 3-phosphate dehydrogenase. So similarly, if you see here, 1,3-bisphosphoglycerate, what will be the enzymes then? That will be the phosphoglycerate kinase will be enzyme. Similarly, DECMake. So what is this? What is the work of the mutase enzymes? The work of the mutase enzyme is just to change the functional group. So actually this phosphate group was in the 3 carbon. It was on the 3 carbon. So and now it is on the 2 carbon. So you can see here it was on the 1, 2 and 3 carbon. Now it has changed to the 2 carbon. So what is the work of the mutation enzymes? Just to change the positions of the functions. So 3-phosphoglycerate is changed into the 2-phosphoglycerate. So after the 2-phosphoglycerate, so what actually happens, there is the involvement of the enzymes called enolase enzymes. So these enolase enzymes will release the water molecules and it will make the phosphoenol pyruvate. And last enzymes that acts is the kinase enzymes. So the kinase enzymes, what will the kinase enzymes do? The kinase enzymes will synthesize the ATP, and the reaction is the irreversible reaction here. And you can see the phosphate is consumed here, and double bond formation will be there, and this is called the pyruvate, and the pyruvate is formed. So overall it has generated the energy. The generations of energy is NADH to NADH, and there is the generations of the 4 ATP. But actually what happens is that in the earlier Kike step there was the 2 ATP minus. So overall they will generate the 2 NADH and it will generate the 2 ATP. So that is the energy, that is the amount of energy that has been generated by the glycolysis. So this is the formula how I used to remember this glycolysis. And you know, this is the very simplest step. If you practice 1 or 2 times, you can remember and memorize it throughout your life. So thank you for watching my video. If you really like the video, please don't forget to subscribe my channel and share the video. Thank you.